Hi, and welcome to EC&M Tech Talks, brought to you by Electrical Construction and Maintenance Magazine, EC&M. This is a series of videos in which we cover everything from basic electrical theory to electrical equipment that we use out in the field, to the different applications, code requirements, of course, including the National Electrical Code. And as I said, this is brought to you by EC&M Magazine. Now, what you need to do is you need to go to ecmweb.com. That's ecmweb.com. And then if you look in the upper left-hand corner, there's a drop-down menu. The very first item on that drop-down menu is called Premium Content. You need to sign up for that premium content. It's free, and there are tons of information that will help you not only with today's topics, but many other topics as well, of course, in the electrical industry. So that's ecmweb.com, and sign up for that premium content. Now, I'm Randy Barnett, and I'll be your facilitator for today's presentation as usual. And the topic we're going to talk about today is boxes, boxes and boxes, huh? Now, there are lots of boxes out there. As far as my background is concerned, I'm a journeyman electrician by trade. I'm the author of Commercial and Industrial Wiring. I'm certified electrical safety compliance professional, as well as worked as an electrical inspector. So anyway, that's a little bit about me. My job is to keep things practical as we go throughout today's topics. So we're going to be talking about boxes today. Now, that's in Article 314 of the National Electrical Code. Article 314 is outlet, device, pull, and junction boxes, conduit bodies, fittings, and handhold enclosures. Okay, but we're going to find some additional information in something called the UL White Book we'll be talking about. And we're going to be talking about the boxes today. So whether they are metallic boxes like this one or non-metallic boxes. For instance, this is a non-metallic PVC box, most common in the industry, and this is a non-metallic fiberglass constructed type box. Now, if you go to 314.1, you'll find exactly what all types of boxes are covered in this article. And I'll just note some of my highlights here. It says, this article covers the installation and use of all boxes and conduit bodies. We're going to talk about conduit bodies in another tech talk. And they're used as outlet, device, junction, or pull boxes, and handhold enclosures as well. They can be made of cast metal, sheet metal. They can be non-metallic, like we just looked at, or other boxes such as FS or FD, and larger boxes that is not classified as conduit bodies. Well, anyway, we're going to look at these standard box sizes that we have in different types of box. We're going to look at the specifics, the installation requirements a little bit, and we're going to talk about how to size these boxes, okay? Something we call our box fill calculations and volume calculations and so on. So we'll be getting into that a little bit. First of all, a few items from UL that you're not going to find necessarily in the National Electrical Code regarding these boxes. The metallic outlet boxes, one of the requirements, and always a point of question I found in classes is that people ask, well, how many extension rings can I use? I can only use one extension ring, or how many can I use? Actually, if I take a look at the UL White Book, the UL White Book is the guide information for electrical equipment. And you can find it if you go to ul.com, or you just go online, you can find it and take a look at it. Lots of information. This is the information on the electrical equipment that we install each and every day out in the field then. So for the section on metallic outlet boxes and extension rings, under the section for extension rings, it says one or more extensions may be used. One or more, huh? And it goes on. Then it talks about there's also, we can use certified boxes for fire rated assemblies, I should say. Connectors, all boxes with concentric and eccentric knockouts in. So if I take and I knock out, here is a concentric knockout on this box, right? If I take and knock this knockout out and I had the hole there, it tells me that hole that's left, okay, is suitable, that knockout is suitable for grounding and bonding. And in fact, it says it's suitable for bonding without any additional bonding means around those knockouts, where you're using circuits above or below 250 volts. Now, You still have to follow the rest of the rules in the code. For instance, grounding and bonding at services and separately derived systems all becomes very important to us. As far as the general requirements for grounding and bonding in these boxes, we can go to Article 250 of the National Electrical Code. For instance, this particular box, it measures 4 inches square and it's 2 1/8 inches deep. And so since it's 4 inches square, we'll commonly call this a 4 square box. There's a little raised portion in the box right where my finger is, or let me grab a screwdriver, my insulated screwdriver, no less, double insulated, not required in this application. But anyway, if I take a look at that little raised portion, then I'll turn around and show it what it looks like on the back. And so that's where I insert my 1032 grounding screw, okay, for bonding purposes. So that's that green screw that you can see right there, okay? And so that's really handy, that raised portion. That's going to make it a lot easier if I mount this box to something like maybe a concrete block wall. I don't want that screw protruding out to where it makes contact with the wall and prevents me from properly mounting on the wall. So that can save you a lot of time in installation anyway. But always follow your rules in 250, especially 250.8 on methods that we can use for proper grounding and bonding then. And you've got to be familiar with Article 250 if you're going to install these boxes, whether they're metallic or non-metallic. We got to do the right thing according to Article 250. If not, remember, all the way back to 90.1, the purpose of the code is to prevent electrical shock and electrocutions and buildings from burning down. And so a good reason for proper grounding and bonding. Anyway, a couple of more items from UL then. For instance, I would not find, here's a box. So this is an octagonal box. It does have 8 sides, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's an octagonal box and it has a clamp in it. Okay? And actually it had another clamp on the bottom and I pulled that clamp out. Now it doesn't tell me this in the code, but what can I use that clamp for? Now, actually, if I look on the box, not on this box, but on the container that they came in, it would tell me what the clamp can be used for. But when I look at this clamp, I pull this clamp out and on the front of the clamp, there's some writing, pretty small, so I'll read that to you. It says AF MCI MCI-A MCC. What does that mean? That tells me the types of cables. So the A indicates that I can use this clamp for a type AC armored cable. The F indicates that I can use it for a non-metallic sheath cable. And then the MC, the MCI, the MCI-A, and the MCC tells me that I can use it for all of my different types of MC metal clad cable then. So I got to know that white book can be very handy for you when you're trying to find out specific information that maybe is not in the code. A couple more things. All of my metal boxes, by the way, they're all suitable for installation in concrete with no other supports. They're all corrosion resistance, whether they're galvanized or part of the powder coating they have on it when they manufacture the box then. One other thing that we run into, and it's actually found in the code book too, it talks about it in 314.15 on damp and wet locations then for my boxes. Now, if I'm going to use and especially when we talk about the cover that we put on these boxes, if I'm going to use a box in a wet location, it's got to be, listed for a wet location. Now, there's provisions in there. I have to have approved drainage openings if needed and so forth. But when it comes to putting a cover on that box, so I'm going to put a cover on this box. And if it's a type cover where it's only suitable for a wet location when the doors are closed on the, say over a receptacle. So if I have a receptacle in this box and when I close the cover, only then is it suitable for a wet location. So I can't leave anything plugged into that receptacle, obviously. And that box can also be marked as suitable for a damp location. Now, if I have the type of in-use cover, where when I close the cover, there's usually a slot in the bottom or the side of the box where I can have something plugged in continuously and still keep the cover closed. And so that's called an in-use cover. So my box can be my box with the cover combination can be suitable for use in both damp and wet locations. And if it is damp and wet locations, then that's that term we see in the code for extra duty. And that has to be marked on the cover of the box then. So that's how that works. Now that's 314.15. Also, I want to call your attention to 314.16, especially because there's been a change to the 2020 National Electrical Code on box fill calculations or box volume calculations and so forth. And well, at least on the box fill calculations. So if I had this box that I mentioned before, and we said this was a 4 square box and 2 1/8 inches deep. So I can go, I guess I could get out my calculator and I could tell you what the volume is in cubic inches inside of that box. But why would I want to do that? Because it's already in the code book. It tells me what that is. So let's go to table 314.16a in the code book. So I'm in my 2020 NEC. And in my 2020 NEC, this is actually page 184. So whether you're taking notes or you have your code book open, take a look at table 314.16a, metal boxes. And that table is the standard size of metal boxes that we have. And for instance, it starts at the very top with trade size, the box trade size, 4 by 1 1/4, and so forth. And so if we measure this box, if we had any questions and didn't know or hadn't seen it on the container it came in, this is 4 by 4 by 2 1/8 inches then, okay? And so we need to find that box, square box, it says, square box, 4 by 2 1/8 has a minimum volume in cubic inches of 30.3. So this box has 30.3 cubic inches volume on the inside of it. Now that's important to understand because that means I can put wires inside of it, whether I'm going to splice them or terminate them on the inside or run wires through it. And we're going to say that each size of wire takes up so many cubic inches. Now that's not an exact science, obviously, when we put a wire in here. But we're going to say, for instance, if my table right below this one, 314.16b, which is the free space within box for each conductor. So for instance, if I'm going to run a number 12 wire in here, it says I have to allow 2.25 cubic inches for that number 12 AWG wire. So 2.25 cubic inches. Obviously, based on my entire box volume, which we said was what? For a 4 square, 2 1/8 was 30.3 cubic inches. Whatever my wires and all the other devices and clamps or whatever it is I may have in this box cannot occupy more than the volume of the box, 30.3 cubic inches then. So I use the tables of 314.16, and I have to do a little math, and I can calculate then what size box I need for my application. So I figure out what is my volume allowance for each device listed in 314.16b. And I look at my table 314.16b and see what my volume allowance is for each one of those conductors. I add all that together, then I can determine what size box I actually need. Minimum size box, right? Sometimes we prefer not to go with the minimum size. Just depending on what we're doing, we may need a little bit bigger. Now, there has been a change to these box volume calculations in terms of that equipment grounding conductor. When the equipment grounding conductor entered the box, we just took whatever the volume was for that equipment grounding conductor and counted that as one volume allowance, or one time. For instance, we said like the number 12, 2.25 cubic inches. But the change for equipment grounding conductor fill, and you can find it at 314.16b5, equipment grounding conductor fill. And it says I can have up to 4 equipment grounding conductors or equipment bonding jumpers enter a box, and I give them a single volume allowance based on the largest equipment grounding conductor in the box. Then if I have anything above that 4, here's what it tells me: to take a 1/4 volume allowance made for each additional equipment grounding conductor or bonding jumper based on the largest equipment grounding conductor or equipment bonding conductor in the box then. So that is a change, that 1/4 volume allowance. So you might find yourself having to get out your calculator and figure some things out in the field and to select the proper size box. So remember, we go through, what we're really interested in is what size box do I need for the job? So I go through and I look at as I said, all my clamps and so forth are listed in 314.16b under box fill calculations. It tells me how many volume allowances to take for a clamp fill, for example. Then I look at the size of my conductors coming into the box, and I add all of those conductors together, except the equipment grounding conductor, add their volume allowances together based on the table of 314.16b. And then for the equipment grounding conductors, the first 4 that come in, take your largest equipment grounding conductor and take a volume allowance for that one based on 314.16b, your free space for each conductor table. Then we look at the largest additional equipment grounding conductor entering the box, and we take a 1/4 volume allowance for that additional equipment grounding conductor then. So that's something you probably need to practice and get a hold of some one of the books or so forth on sample calculations on that and work through that if you have any questions. Righty? A couple other things we want to bring out about our boxes. And there are actually 4 parts. Yeah, there's part 1 in Article 314 is general information. Part 2 is on installation requirements. And part 3 is on the construction requirements of these boxes. Now, the final part then is on for boxes over 1,000 volts. Right? Also, another important section through here is 314.28 for pull and junction boxes and conduit bodies. So how do I size my pull box? And it depends on whether or not it's a straight pull through the box or an angle or U-pull. Okay, that's going to determine what size pull box that I need. And so that's another good example where you need to work through a few of those examples if you have any questions on that. Now, the bottom line is here for the straight pulls, the straight pull, it says you take the length of the box or conduit body shall not be less than 8 times the trade size of the largest raceway entering the box. So there we look at what's the largest, if it's a straight pull right through a box, we take a look at the largest raceway and we multiply that times 8, and that's going to give us the size box that we need then, the length of the box, okay, in order to pull those conductors through there. Now, angle and U-pulls get a little bit more, just a little bit more complex. So once again, for all of these calculations, it takes practice. This is not anything you're going to memorize right or have right off the top of your head. So use the tables. They're there for a reason in the National Electrical Code. Refer to them as you need to. And then for your pull boxes, of course, look at 314.28. All of your construction specifications for these boxes that we're talking about are found in Part 3, whether they're PVC or metallic type boxes and so on. This particular box is very important to us, and that's a utility box, it's called, or we just more commonly refer to it as a handy box. But it is a standard size box, and you can find its volume information in the table 314.16a then. Right? So that is our information on boxes that we have time to cover today. There's a lot more to it. Be sure to take a look at all of your installation requirements. Extensions are allowed to be used. Be aware of that. So here's a non-metallic extension for a non-metallic box we talked about, and that can add additional volume to my box as well, which may be able to help us out in some distances. Also take a look in your NEC for the distance. Once I put a device inside of this box, what is the distance between the back of the device and the back of the box that I must have? And that depends. You'll find those, way back Depth of boxes, 314.24 then, for something they call large equipment, and then based on different conductor sizes. So you're probably running a lot of maybe number 14 into a box like this. So take a look at 3.24 depth of boxes, and the subsection would be B5, conductors and 14 gauge and smaller. It's going to tell me that between the back of the device and the back of the box, I must have at least 15/16 of an inch. So you can take your tape measure and you can measure that, can't you? Okay, got to make sure you've got that. So as I say, that is boxes for today. And thank you for listening. Remember that this is brought to you by EC&M Magazine, and they're part of the portfolio of the Endeavor Business Publications. Thank you for attending today, and we'll talk to you in the next Tech Talk. Where we're going to be talking about circular raceways, conduits, okay, and what's going on with that. So until then, work safely. That's what matters out in the field.